Why do robust electronic components fail unexpectedly? Imagine holding a device that has been tested to last 4 years, yet suddenly it stops working without warning. It seems strange that something built to be tough can still break down unexpectedly. The truth is, even the strongest electronic parts can fail due to many hidden or sudden issues. Let's explore what causes these surprises in electronic component failures. Electrical overstress happens when a component receives more current or voltage than it is designed to handle. This excess can cause internal damage, like melting tiny metal parts inside. Electrostatic discharge is a quick, high-voltage static shock that can fry delicate circuits instantly or cause tiny cracks that worsen over time. These electrical stresses often come from poor wiring, grounding problems, or electrical noise from nearby equipment. Thermal stress is another big factor. When electronic parts heat up too much or experience rapid temperature changes, the materials inside expand and contract. This can create cracks or cause layers to peel apart. If a device gets too hot, it can enter a state called thermal runaway, where heat builds up faster than it can cool down, leading to melting or even fires. Devices operating outside their temperature limits tend to fail suddenly because of this. Mechanical stress can also cause failure. Shocks, vibrations, or even tiny movements from differences in how parts expand when heated can crack the fragile semiconductor die or its packaging. If manufacturing processes like cutting or mounting are not perfect, tiny defects can form. Over time, these defects grow, causing the device to break or lose performance. Environmental factors play a role too. Humidity, dust, or chemicals can cause corrosion or oxidation inside components. Moisture can create conductive paths on printed circuit boards, leading to shorts or open circuits. Radiation from sources like sunlight or space can alter material properties, making parts brittle or causing them to fail. Materials inside components age over time. Electrolytic capacitors can dry out, losing their ability to store charge. Resistors or inductors may change their electrical properties as they wear out. These gradual changes can cause a component to suddenly stop working or behave unpredictably. Manufacturing defects are another cause. Impurities or poor bonding during production can create weak spots. For example, soldering with higher temperatures needed for lead-free solders can cause tiny cracks or conductive filaments inside printed circuit boards. These defects might not show up immediately but can lead to failure later. Sometimes, a small initial fault can trigger a chain reaction. If a metal line inside a chip breaks, it can cause voltage spikes that damage other parts. This cascade of failures can happen quickly and unexpectedly, especially in complex circuits. In real-world cases, these failure mechanisms explain why even robust components sometimes fail without warning. For example, in aerospace, parts are tested under extreme conditions, but unexpected failures still occur due to hidden stresses or environmental factors. Engineers use burn-in testing to catch early failures by stressing components before they are used. Proper grounding, shielding, and environmental protection help prevent many of these issues. Knowing how these failures happen helps engineers design better, more reliable systems. Using improved packaging, thermal management, and strict quality control during manufacturing can reduce unexpected breakdowns. Regular monitoring and maintenance of electronic systems also help catch problems early, preventing catastrophic failures later.